So, fun claim about Q's. So, the Q's, I'm just going to say Q is, so any of the Q's, right, is an angle and length preserving map. Okay, so quick reminder, what does it mean when I use the symbol Q? You guys remember this yet?
Matrix. Those vectors are what's the normal?
What vectors?
The columns.
So orthonormal columns. Perfect. So I've got my matrix. What's the other thing I should remember? This is the sign for teacher. So I did this earlier, and you all should have done this.
Doesn't have to be square.
Excellent. Perfect. So possibly not square, right? What does it mean to be an angle and length preserving map? Who the hell knows? Okay, so let's define length preserving first. So length preserving is going to mean that if I do Q to a vector, perfect. It doesn't change the length, right? So if I do the matrix Q to a vector, the length of that is the same as the length of the vector. Is on board with that? Okay, cool. That's what it means to be length preserving. What does it mean to be angle preserving? Perfect. So if I have a picture like this, right, where the angle's theta and I've got a vector x and a vector y, when I do Q to that, I'm going to get two other vectors, right, somewhere else. Maybe they look like this. They're qx and qy. And I'm going to be able to say that the angle between them has to
be conserved.
Stay the same. Yeah. Essentially, this is kind of conservative, right, from physics. This is like length and angle conservative. Okay. What the shit? How in the heck am I even gonna lay my hands on this? Are you gonna get a protractor out?
Well, wait, on the angle using the dot product, and the dot product is the vectors that are modified by the normal lines, and those vectors, we take the equals go some point.
Perfect. Okay, so I hope the rest of you all heard enough of that to get the gist of it. Orion, shut up. Okay, so what did he say? What was the gist of that? Where can you get the angle from?
In the cosine, what is it? The dot product divided by the magnitude?
Yeah, so let's just start off with the dot product, right? You guys with me on that? Like, I don't know about this arc cosine friggin' nonsense that was talked over there. Let me just start by saying that maybe there's something to do with dot products. You guys recognize that dot products might get me something here too? The length of a vector is its dot product with itself, right? Square rooted. Okay, so I might be able to get away with some of this, right? If I'm like, okay, I'm just going to talk about the dot product, right? So I'm going to say that I did Q to a couple of vectors. You guys with me on this? Like, I don't know. I'm just going to supply myself with two vectors, x and y. Where are those vectors going to have to be? hell, I don't know. I just did Q to them, so they must at least be in the domain of Q. I probably don't know anything else. So if I had to kind of, if you pressed me to write this out in math, I'd be writing, let x and y be in the domain of Q. If I had given Q some size, right? Like if I had said Q is m by n, I'd be saying, let x and y be in Rn. You guys with me? So I got a couple vectors. What am I going to do with these? I'm going to dot product them. How do you write the dot product of vectors? You guys remember that? No. The rest of you remember that. How do you take a dot product between two vectors?
You multiply each component, corresponding component, and add them all up.
That's going to be hard for me to do here.
Outer products also.
Yeah, so outer products are the other one. I want the dot product, which is the inner product. So how do you take a dot product with transposes? Well, you take the inner product. So which one do I transpose? The first thing or the second thing? Yeah, I have to take a column, right, and drop it onto a row. So that's going to mean that I need to take this column vector and turn it into a row vector, right? So I'm going to say that the dot product is the same thing as taking qx and transposing it. Right? That's going to take my column vector, turn it into a row vector, and then I'm going to multiply that by qy. And you got to be careful here because the outer product, the sizes would work, but it wouldn't tell you anything. Just remember that? So, how do transposes of products work? Like if you have A, B, and you're doing the transpose.
Reverse the order.
Yeah, you have to reverse the order so the sizes work, right? So, we can say that this is X's transpose times Q's transpose times Q times Y. And what was the cool thing we learned earlier?
Q transpose Q is the identity.
Good. Q transpose Q is the identity. So this is X transpose Y, which is another fancy way of saying that's X dotted with Y. You guys see that? So, I'm a little bit out of time here. Angle and length preserving, both of those are phrasable in terms of dot products. And what I just demonstrated is that Q preserves dot products. You guys see that? So that should be enough to demonstrate angle and length preserving. First, say, okay, if y is x, right, then that's the magnitude of x squared, and this is the magnitude of y squared, qx squared. Isn't it? So if we let x and y be the same vector, then I have q, the magnitude of qx squared is the magnitude of x squared. That tells me they're the same number. How do I know I don't have to deal with a plus or minus in here? Like, how do I know I can square root both sides of this and not have to deal with a plus or minus somewhere? Good, it's a magnitude, so it's automatically positive. You guys with me on that? Okay, cool. So Q is length preserving, and then the fact that it's length and dot product preserving will give you angle. Because Orion said that you can define the angle. So do you guys remember how to define the angle? You said that word, the magic word arc cosine, which is part of it.
Is it the dot of the 2 on the top?
It is x dotted with y on the top divided by,
Is it the magnitude or magnitude squared?
it is the magnitude of each one multiplied together. Right, that's A dot B is mag A, mag B, cosine angle between them. You guys good with that? So this will tell you that the angle's preserved because all this is preserved. Good?
Just a little thing. When
Yeah.
you said Q transpose times Q equals the identity matrix, you put
Yep.
a transpose.
This guy?
Yeah, but you put an X transpose right there?
I did put an X transpose right there.
Okay.
Because in order for me to multiply the vector X times the vector Y as matrices, I have to turn X into a row vector. So
Oh, okay.
this thing is the identity matrix, that leaves the transpose on X. So I get X transpose times Y,
Mhm.
and then that's just another way of saying the dot product.
Alright,
Is good?
cool.
Okay. Hey guys, sorry for so much lecture today.